Hey guys, it's Mr. Dugal, and today we're going to talk about the exterior angle theorem. And how I like to describe this theorem is that it's something that you have had the skill set to do and that you just might not have realized is true. This is how the exterior angle theorem works. I'm going to show you why it's true, and then we're going to do a couple of problems and show what we can do with this theorem. So the first thing is we know that triangles add up to 180 degrees. And to look at this first blue triangle here, we also know that when we have supplementary angles like this, two angles that form a straight line, that the angles combined add up to 108 degrees. So if the angle on the left is 70 degrees, that makes x here 110, because 70 plus 110 is 180. Now, what I want you to think about is that if x plus 70 equals 180, and 72 plus 38 plus 70 equals 180, then what must follow is that x equals 72 plus 38. And what this means is that our outside angle here, this is called our exterior angle, always equals the two interior angles. Now there's deeper ways to prove this, but just to use an example in a brief way to show this is true, is because these two angles will always add up to 180 because they'll always form a straight line. And these three angles here will always add up to 180 because they'll always form a triangle. What that means is that the angle on the outside will always equal these two angles here on the inside. So in our example below in the red triangle, we don't even have a third angle here. Obviously we can find it if we need to. We actually don't need this third angle to determine y, and that's because we know that y equals the sum of 63 and 39, because the angle on the outside, the exterior angle on the outside equals the two opposite interior angles. So y equals 63 plus 39, which means that y equals 102 degrees. If I wanted to find this, be 180 minus 102, that would have been 78. Question doesn't ask for that, it just asks for y. Okay, the last thing that this might mean is that we can actually use an exterior angle to find two missing angles of a triangle. So up to this point we've been given questions where we might be given two angles to a triangle, we're missing the third, like with the red triangle, but you haven't been asked to solve triangles where it's missing two angles. I want you to think for a second, how can I use my knowledge of the exterior angle theorem and the fact that I'm given that this angle is 42 degrees to determine the remaining two angles? Okay, the reason this works is that we know that 42, and let's just call this x and this angle y, plus x equals 113. Because my two interior opposite angles here equal the outside exterior angle, which means that x here is 71. And there's actually two ways I could find y now. I know that y is the supplement of 113 here. I also know that 71 plus 42 plus y equal 180 in a triangle. Obviously this is 113 because it's the same as this angle here. And 113 plus a number equals 180. That number is 67, y is 67. Just to check myself, I'm going to add up my angles of the triangle to make sure they're 180. And of course, they are 180 degrees. So that means that x is 71, y is 67, that I'm all set. So that's how the exterior angle theorem works. Again, the outside angle, in this case it was x in the blue triangle, equals the two interior angles opposite of it. Thanks so much for watching. Hopefully this serves as a solid foundation for how to utilize the exterior angle theorem.